well, first of all, thanks to Chris and Iteration Insights folks for having me. I appreciate the opportunity. And also thanks to James and Pratik for their great presentations as well. So today I'm going to be talking specifically about building analytics components with Terraform. So it's a declarative language for producing some of the infrastructure. There's some common themes in the discussions with James and Pratik, in that they talk about environment management and the complications surrounding certain folks within the organizations, be it a business user or a data scientist, maybe not having a full grasp or even wanting to have a good grasp on infrastructure components. So hopefully tools like this help make building those environments much more reliable. A little bit about me. I'm a senior cloud engineer for a major Canadian airline. Been in the IT business for over 23 years, 11 of those in the airline industry specifically. I can never really get very far from Microsoft technologies. That's been one common theme throughout my career the whole time. I've held roles as a developer, automation engineer, in SharePoint, and more recently in DevOps. But in the last several years, my focus has purely been on data science, data engineering, analytics, visualizations, and machine learning. Hopefully, if the presentation is shared out, you'll have access to all the contact details, and I certainly welcome any feedback that anybody have. Just start with a couple quick legal disclaimers. Hate to have to do this, but I'm going to be showing code, and if somebody accidentally runs up a cost that they didn't anticipate, it's not going to be my issue. And also that everything presented is just on an as-is basis. A little bit of an agenda. So I'm going to talk a couple of things about two tools that are going to be involved in this. So Azure CLI and the Terraform CLI. And then we're actually going to get into actually provisioning some data analytics resources with Visual Studio Code. Time permits, we'll talk about some what's next steps and references to links, etc. So specifically what we plan on working today, things that are in scope and out of scope. So in scope, we're going to be building service principals and IAM permissions. So these are the low level Azure type things that a lot of people don't want to have to deal with or even want to have to understand. We're going to provision an Azure Data Lake, Azure SQL database, a database within that server, Azure Key Vault for storing secrets, a data factory instance, Databricks instance, the associated VNets and subnets that would go with that Databricks instance, and a log analytics workspace where we can get some of our monitoring data. Just because it takes time to write all this code and demo stuff, I had to, of course, exclude some things. So I have chosen to exclude Power BI, Cosmos DB, cognitive services, any detailed security advice, Synapse, Azure Machine Learning, containers, Kubernetes services. Not to say that Terraform can't work with a lot of these technologies. It's just I chose to kind of go from a little bit of a ground up type build. For the topology, it'll look a little something like this. So we're obviously going to be starting from nothing and start build out an entire resource group. Within that resource group, we're going to have the Azure SQL database components, the data lake, and the container built within. Of course, just like I've said a couple times now, it's never usually just like one object that allows you to get moving in Azure. There's usually a combination of some object that you need, some permissions that you need, some security configuration that you need, networking, all types of things. And what we're going to see here is in this, this one fell swoop, we're basically able to pull off everything. Policies is a good example of that. So I'm going to be building out an Azure Key Vault and putting secrets in it and then applying policies on it. Just so, if we're working with a data scientist type role, they probably won't be as interested in working on low-level policies, but of course your security administrators within the organizations are going to want to apply governance policies, right? The whole right side of the diagram here is, of course, all the Databricks components. And again, speaking of governance, one thing that's really nice here is when we build this out before provisioning the Databricks environment, if left as is, basically Azure will create this long string of text to give the resource group name where those Databricks compute resources are actually built out. Using this type of infrastructure as code technique, we're able to actually put a finer casing around that. We're going to provision a data factory and actually link up some of these services, so the data lake and the SQL database. Forward all the diagnostic information to the log analytics workspace, and of course provision a couple service principals. So that's basically the gist of kind of the topology that we plan to build here. So if I just quickly hop over to Azure environment. As per the diagram that we just looked at, here's an example of what I'm calling the dev environment. So by the time we're done this talk, we're actually going to build out a like-for-like QA environment. And with the change of one more file, we could build out a staging environment. The change of one more file, we could build out multiple production environments. So hopefully you start to see the benefits of a uniform kind of environmental configuration where some of the low-level things are taken care of. Here's the example of the Databricks cluster as the Databricks environment here was being built out. This resource group with a very similar name. So of course it creates some uniformity in the naming conventions there. Switch back to PowerPoint. I think we covered everything on there. Oh, in the data factory, we're gonna get set up with a basic pipeline and data set and some other configurations like that. We'll talk very quickly and then kind of move past this. Anybody not familiar with Azure CLI? It's a command line utility. One thing I've always been proud of in my career is I was never really afraid of the command line going way back. So the command line utilities have always been very familiar to me. And it's a little bit surprising, to tell you the honest truth, that in 2020, they're still as prevalent today as they've ever been. So of course, Microsoft provides one called the Azure CLI, or the command is actually just AZ. And we're going to be using version 2.6 in this, and we need it to authorize ourselves into the subscription. Just a quick summary on its use. On a command line, type the letters AZ. In this case, we're passing in a version flag and getting back the version 2.6. One of the most useful things that you could probably get yourself into, I know a lot of people that are intimidated by the command line are simply just confused with how many options are available. The -- help flag is saving grace there. So of course I didn't print out the entire output of that. You can try it on your own machine, but an example of what I'm trying to highlight here is within the AZ command, it's going to show you all of the different subcommands, or what they call subgroups. So if I flip over to the next one, this is basically showing how you can get detailed help on basically any command. So the first one we looked at was AZ -- help. This is AZ account -- help. And now, of course, I'm going to get specific information and specific detailed usage instructions on that particular one. So we would use AZ account on this one to during the development of Terraform, it's frequent that if you're working in a multi-subscription environment, that you have to try to understand which subscription you're working in, and double check to make sure you're not, that you are working in the area that you think you are working in. Another example just of that, in that we just keep adding to the command lines here. So we are now looking at the subgroup that they call the count, and then within the account subcommand, there's all these clear, list, set, show, and so forth. And now, of course, you can just keep on putting -- help on the end of any one of those. So now our command is AZ account set. So I'll pretend that I don't know what that does. It's going to show me that if I were to run that command, I have to pass in a subscription argument, and of course, the name or ID of a subscription. Here's an example of AZ account show. Of course, you basically get a JSON response back, which is pretty normal for most of these command line utilities. Get a command line response back that gives you some details about your tenant information. So prior to actually executing any Terraform, of course, you have to have a context into the Azure environment, and that's done through AZ login. So in this example here, AZ login -u, and then my user identity. And basically, after I successfully log in, of course, it prompts for a password, multi-factor authentication, like whatever kind of authentication system you have. After you successfully log in, you're basically going to get this type of output again, just kind of confirming for you that you've successfully logged in. So moving on to the Terraform CLI, of course, it's an open source cross-platform application for infrastructure as code. It's both an open source product as well as a commercial product. In this example demo, we're going to be using the open source version 12.25. The producer of the utility has providers for Azure, AWS, Google Cloud, Alibaba, so on and so forth. So this is not just an Azure specific thing, which is, again, of course, one of the selling features of doing this. Microsoft's infrastructure as code technology is called ARM, or Azure Resource Management Templates. Some people on the line might be familiar with that. That's, of course, a JSON-based coding language to be able to produce infrastructure as code. But of course, the one downside to that technology is it only works in Azure. Whereas HashiCorp, the company that produces Terraform, the product, they specifically work with all these vendors and their APIs and are able to, just with a short delay, after new API functionality is released, after a short delay, they're able to provide that functionality in their product. So one thing that it is not a configuration management tool like desired state configuration or Ansible or Chef or Puppet. And a good introduction video is going to be included in our the reference slide at the very end, which actually the HashiCorp co-founder is produced. Just like we talked about with the Azure CLI a little bit, the -- version tells us what our version is. I can the uniformity, a beautiful uniformity -- help, of course, provides all the help. You can see my common commands here at the bottom. So of course, Terraform is the name of the executable. The amount of options that I can include things like apply and console. Again, this isn't a complete list. It's you can try it on your own. I can keep putting -- help on anything. So Terraform apply help if I want to try to get a better understanding on what that command is or it does. So here's basically the magic of the system. It's a 3-step workflow. Terraform init, Terraform plan, and Terraform apply are kind of the three steps that you have to walk through. So Terraform, actually, I'm just going to sidetrack here. Go back to, let's go into Visual Studio Code. And I am actually, because just to save us some time, I have actually ran the plan phase, which is the second phase in that workflow, to create our QA environment. So our command is Terraform plan. I'm passing in and I passing in some secrets because, of course, I don't necessarily want to share that with everybody on the call here. And it's going to produce a binary plan file. So while we talk about the slides for a second, I'm actually going to run my plan. So we have something to come back and look at. So the init phase basically loads the remote state, pardon the spelling mistake, downloads providers and modules from HashiCorp themselves. The plan phase creates the binary execution plan file, and apply actually goes and makes the changes to the cloud environment. So this is a very smart system. You're able to rerun commands over and over again, and if proper management of this state file is handled, you're in a position where you can incrementally improve the environment without having to worry about rerunning the script or destroying everything. So we got through we kicked off the apply phase. So let's kind of hop back to the I'm going to just do this troubleshooting step here. Just like any kind of technical capabilities development, if you will, there's some troubleshooting steps. This is my personal experience There's some times where you basically run into a little bit of trouble, and these 3 steps, or a combination of these 3 steps, will get you out of everything. We're going to see when we look at my development environment, there's a local folder called .terraform. The Azure account credentials can be corrupt or lost or cleared. And so basically the troubleshooting steps would result in me deleting that Terraform folder. So I'm gonna drop all of the downloaded artifacts from HashiCorp, run the AZ account clear. So basically clear all my credentials from my development workstation, actually log in again successfully, and then rerun the init plan apply workflow that we've been talking about. So let's hop back to the VS Code. So that's still running. We'll just quickly glance over the, how am I doing for time? Oh boy. Quickly glance over the project. Here's the .terraform folder I talked about. So since I've ran the init, we've actually pulled all these providers down from HashiCorp. I didn't have to wire in any connection information or anything. I just knew how to do that on its own. I have, we will just talk quickly about some of the capabilities. So without going into grave detail or doing a thorough code investigation, there's concept of variables. So you can see this whole file is simply variable, some name, and then some definition. You can get it more specifically as data type and so forth. So in this particular case, I am actually filling out the values in this file called variables.tfvars. And if I look at this one, so subscription ID, actually, let's use this one. So the variable resource group name is actually the value. This is what it's actually going to build when it builds. Finally, there's basically the main. So how we're able to build out all these environments is the logic in this code right here. It's quite simple to understand, actually. In my personal opinion, much easier than ARM to understand. Because this example right here, everything that I have highlighted here is the creation of a storage account. Hopefully everybody can see that. This is actually going to create the storage account just in and of itself. So it's going to take the name from that variables configuration that we've seen. It's going to use the resource group name that has also been specified in this script. So at runtime, it actually builds this intelligent graph of all of the things that it has to build in what order in order to actually build out the environment. So just to kind of show you quickly, the only real difference, like when I run my environment to build out a QA environment, if I were to do a difference on these 2 files, all that we're going to see here is they have all the same variable names. And the only difference is everywhere where it says dev on the one side, it says QA on the other side. So of course, after the execution of this, I literally end up with the exact same environment, just a second copy of it. I'm sure almost everybody on the line has experienced a scenario during their work experience that has resulted in environmental configurations being the cause of a bunch of lost time and tears. So that's just a super high level of Terraform, the concept itself. One thing that we kind of need to keep in mind is that as it produces the state file, oh, still running it, that's probably why. It's important to know that the state file, if left running here, actually contains secret information in it. So in our scenario, we're actually building out a database. The database user has a password that is actually in clear text in here. So there's some security considerations that the development team or any implementer of this kind of technology has to keep in mind before they share the files. That could be done through as simply with things like .getignore file. So remember how I was saying I had defined some secret variables in this folder here called secrets. I just basically excluded it from my commits. So now I can kind of safely send up to GitHub any of this project. So let's check in on our build. So it actually completed. I'm just going to very quickly kind of show you an example of some of the output. So when we did the plan, this is the system's method of saying the green plus icons are indicators that this is new. They have other ones for saying something has changed and other ones for something that's deleted. Like I said, the system is not just about creating things, it's entire environment management, from temporarily deleting some things, leaving other things, changing other things, any combination that you can think of. So when we applied that configuration, it actually executed, built out all those things. You can see here, Databricks took a little bit longer, took 4 minutes to actually build that out. And at the end, it said we built out 38 resources, and I've specifically in the code expected it to output some of the service principal information that I have. So now, if I were to, if you remember earlier, we looked at those resource groups. You can actually see in my resource group here list, we have no such thing called QA. If I come back and refresh that, I will have a QA resource group, and there's all my objects. This is literally all just built out since we've been on the line. So let's kind of quickly look through a couple of things here. On a SQL Server, we have the local username and password have all been supplied. We have what was I going to look for? The firewall configuration is something that was set, and the diagnostic information is something that was set as well. So actually, I think that's on the database itself. Oh, we got somebody coming in the house here. Pardon the noise. So here's our diagnostic settings. So the script actually set all this stuff up as well, because again, depending on the type of data role that the person has, they probably don't want to have to consider these types of things, but almost assuredly, the policies through in the company definitely do want to see these things implemented. That's an example of the SQL Server. Quickly hop over to the data lake. So there's our data lake that's set up. You can see it's Gen 2 storage. If I scroll down to the data lake containers, it actually built out our container. Of course, there's nothing in it because now it's the whole intent of this was to build out an environment that somebody was able to use. Like we talked about before, diagnostic settings for that particular environment are all being set up and wired over to our log analytics workspace. So the script actually built out a log analytics workspace, configure diagnostic settings to push all those things in that direction. We have our data factory. And let's hop over into the author configuration just to show some of the stuff that ended up in here. So during the execution of the script, just like James was showing earlier with some of that fancy Synapse technology, of course, you're going to need your pipelines and your workflows are going to need linked services. So here's a connection to our SQL server. Quickly test our connection. It's actually using a local SQL user password, and the data lake connection using the service principal that was created. So during the execution, this actually created the service principal, created this linked service, linked them together. So therefore, of course, just like with Synapse, if we get into we want to start a rudimentary user on a copy workflow, for example, I'm partly already there, right? These configurations were already in place. That's the data factory. Databricks quickly. So again, I'll go back to my QA environment, and you can also see that I built out a QA cluster resource group, and the system automatically provisioned a storage account. But if I were to drill into the Databricks workspace itself, while we're waiting for that, we can kind of confirm showing our VNet integration and the private subnet that's necessary for setting these up. I will quickly go grab myself a token for the REST API. You guys can feel free to copy that if you like, because it's going to be destroyed by the time we're done this call. So I'm actually just going to go create a cluster with Postman using the REST API. All I need is those two information, the account URL and the authorization token, and make a call to the cluster/create endpoint. And this infrastructure was just built since we've been talking. We got a cluster IP back from the REST API. So now what we're going to see here is in Databricks, we hop over to our clusters. It's currently a little bit delayed there, but if I hop over to our resource group that was being built out that was necessary for the Databricks cluster. We'll give this a little bit of time there. You can start to see the Databricks cluster starting to be built out. And all the compute resources that it's building are going to be in this resource group, which is going to keep some of your governance folks happy, and that it's they're nice, cleanly put away there. So that was basically a super high level walkthrough. So the one last command that we're basically going to talk about is the Terraform destroy. So in the same way that we were able to build all that stuff out, I'm basically able to wipe everything out. Actually, to prevent myself from making a mistake, I'm going to copy it right out of my README file. And this is going to be smart enough to basically wipe out my QA environment, everything that I had there, because I might want to be saving some costs, right? I might want to just be running this during business hours or something like that. Oops. And that's going to go through a workflow of actually tearing it all down. So let's hop back to the slides quick, try to keep us on time. So what's next? Both the presenters before me talked a little bit about Azure DevOps. So of course, we want to probably take it out of a local workstation and actually start to run it in a more automated way. Again, the beauty of the command line utilities is that all these utilities, like such as Terraform Cloud or Microsoft Azure DevOps or GitHub's Actions, all basically use these command line utilities underneath the hood. So basically everything that I just showed you on the workstation, you're able to do in an automated way using these tools. We clearly don't have enough time to go through that today, though. Here's some references, some of the Calgary Azure Analytics and Iteration Insights user group that Chris was talking about earlier. Here's a really good Build 2020 presentation about the future of ARM templates. I kind of recommend that one. They've got some interesting things coming. The open source nature of the providers that we talked about. So this provider that we were using in this code was the Azure RM provider. Terraform's module registry. Here's the YouTube video, the overview of Terraform that I was talking about. Video learning sites like Pluralsight have tons of resources on Terraform. There's courses for data professionals, courses specifically for Terraform itself. And that's basically it. So again, thank you to Iteration Insights. Thank you to Microsoft for their Azure platform. Thank you to HashiCorp for their Terraform product. And thanks to all you. I know I'm kind of the last person holding you back from beer o'clock. So we'll just leave it at that.